Beautiful. So today we are talking about multi-step equations and simplifying expressions. We've already done quite a bit with simplifying expressions. So it's really important to make sure that you're good with how to show work, all of that stuff. Yes, I will be putting in some sort of assessment for next week. So just so I can see how you guys are doing with all of this equation stuff. So yeah. Hello, person who just joined. Hello. So today we are, oh, Cece. Hello, Cece. So today we are going to simplify expressions and solve multi-step equations. So this is what is due this week. Ignore that live lesson. That is from the other class, that live lesson. But, you know, you get the idea. Your live lesson is today. Okay, I'm just hitting save on that. Cool. Shush. Somebody got shushed. Oh, man. Nothing here. Yeah, no, you have today's live lesson, but you have, oh, it's okay. That happens. No big deal. Yeah, but we are going to go through all of the equation solving stuff because we really got to have distributive property down and solve or combining like terms down. So that is a good goal for us today. Okay, so first thing is we want to focus on that distributive property. And I'm actually going to switch to this one here, this -3 times 5y minus 10. We're going to do that one first. So for that one, I'm going to move my chat menu there. First things first, whenever you guys have something, oh yeah, someone wrote on the first one already, you're totally right. So, yep, we would, oh, they added there. Good, that is so good. They added, and it's really good we're talking about this, because when we do distributive property, you're actually multiplying. That's the thing that you want to do, and you want to multiply with your first term and with your second term. That's how we want to do it. Yep, and parentheses tell us to multiply. Very good. So 2 times 3x and then 2 times 7. What would I get if I simplify that expression using the distributive property? What do you guys think? What's 2 times 3x? Yeah, very good. We would have 6x plus 14. And can I combine those at all? No, cannot combine them because they are not like terms. Good, very good. All right, next one there. So first thing I want you guys to see is how it says 5y minus 10 in the middle. Because of the x, yeah, this 6x has an x and this 14 has no x, so it's not like terms. Very good. So hold on before we actually do the distribution. You guys are on the money. I love it. Very, very good. But you see how it says that 5y minus 10? What do we change that minus 10 to? Money. What do you change that minus 10 to? Plus, yep, plus, and then what turns negative? Yes, very, very, very good. Ooh, Annabelle, good work. But let's write this stuff down. Very, very good. So we want to change this to, and the 5 wouldn't go negative. It would actually be that 10 that goes negative. Because we want to have we want to kind of slide it to the right. So it's actually changing to plus -10. And some of you don't need to do that in order to actually do the math, because you guys are doing it very effectively down there. But every time you have a subtraction problem, just remember that that is the same as adding a negative. Exactly the same thing. And sometimes it helps you really see what's negative. Yep, it would be 5y plus -10. Right. Good. So now we can do the distribution. We can multiply. We can go -3 times 5y. Right. Yeah, it's going to turn negative. You're right. Yeah, I was just meaning that the 5 wouldn't be negative right there. It'll be negative after you multiply it by that -3. Good question. Yeah, no, great question. And then we're going to go -3 times -10. So then we would go ahead and simplify and do the math, and someone actually did it down there just fine. We have -15y, very good. And then -3 times -10 is 30. Yeah, very good. -15y plus 30. And we can't combine that. So that's it. Good stuff. Questions on the distributive property and how to do it. We've done it a lot. Please don't move ahead yet. You are absolutely right. That's very good. But I just want to raise up 1 point with that one. Okay, good work, you guys. Okay, really quickly with this last one here, I want to bring up, someone already wrote it on there and they did such a good job, very good. But whenever you multiply by a half, that is exactly the same as dividing by what number? It's the same as multiplying by 0.5. Yeah, but it's the same as dividing by what number? Someone wrote it right on the screen. By 2. Yeah, by 2. Because whatever's in the denominator ends up, like if we go 4 times 1/2, we're going to turn that 4 into 4/1 and then multiply straight across. You end up with 4/2. So it's the same as just dividing by 2. So all you got to do is distribute that 1/2. And you're really like dividing by 2. Yeah, that's what it is. And if you multiply by 1/3, that's the same as dividing by 3. Multiply by 1/4, that's the same as dividing by 4. So it's good just to keep in mind because it makes it go quicker. So we get 1/2 times 4x gives me that 2x that someone wrote on the screen. We have a minus in the middle of our problem. And then 12 times 1/2, or 12 divided by 2, is 6. Very good. Very good. Good stuff, guys. Any questions with that? Okay, if you find yourself struggling with the distributive property, let me know. We will work together. Okay. I was going to say it wrong again. Jojana. Were you pretty comfortable with that? Have you seen that before in your other school and stuff? Okay, cool. Very cool. Beast. Oh, I thought someone wrote beast. Be a star. That's different. Yes. Annabelle has creative pencil holding techniques. I love it. Very good. Okay, so now we want to combine some like terms. And when you guys do this, I really want you to keep in mind changing to that plus negative. So every time you see like 2, oh, I was going to write on there, it didn't work. 2 minus 4, that's the same as 2 plus -4. So let's change that n minus 4 minus 9. Let's change that to those plus negatives. What would that look like if you did that? plus -4, yep. Yep, and then what about the 9? Plus -9. Good. Very good, you guys. You got it. Good work. Okay, so now we can clearly see what's negative. What can we combine there? What are our like terms? Yep, the -4, and the -9. They are both numbers. So what do we get when we combine -4 and -9? What would we get there? Not 5, because remember with negatives, they're both negative. So you're going to get more negatives. It's like saying I owe you $4 and then I owe you $9 more. It would be 13, and it's still money that you owe, right? Don't get confused with multiplication. With multiplication, 2 negatives make a positive. But when you add it, you get -13. And it's okay to use a calculator to check your work here. Totally fine. Totally good. So our final, and that's when you multiply. Negative times a negative is a positive. Yeah, but when you add 2 negatives, no, it's okay. When you add 2 negatives, you get more negative. So this would be our final answer there, n plus -13.
I was always taught that a negative plus a negative equaled a positive.
That is with multiplication, and it's very, very commonly confused. But if you're adding 2 negatives, then you just get a bigger negative. Because when you think about something that's negative, it's money that you owe, or it's something that you don't have.
To be fair, my old math teacher didn't really teach us anything. If we had a question, he would just put the answers in front of our face.
Oh, that's not good.
Like he would just like show us the answer book.
Yeah, that's not good. The amount of blankets you have right now. So Cece lost 4 blankets, and then she lost 9 more blankets. So altogether, she lost 13 blankets. Oh no. Yeah, that's how I feel right now. I'm freezing. Okay, let's talk about this other one. So, oh, I like those. Cha-cha dancers. Cha-cha-cha. Okay. So with, I don't know. It's kind of a weird example because you really can't like, or if maybe someone stole it. My children steal my blankets all the time. My daughter now has like 700 blankets on her bed. Yep, I'm with you there. Okay, so let's change these to adding negatives. What would that one look like? Thank you. What would that one look like there? -3 minus 9 plus 15. If we change it to adding a negative. Yep, very good. Good work. Yeah, very good. Both people have it. Nice job. Excellent. So now we can clearly see what's negative. So what would we combine? What are our like terms? Yeah, the -3x and the 15x are our like terms. Very good.
Oh.
So that's what we are going to combine. So what is -3 plus 15? That would be like if Cece lost 3 blankets, but then she had 15. Someone gave her 15. 12, yeah, that would be 12. Good. So we'll have 12x plus -9 as our final answer. And you can tell we really didn't need the 9 to be a negative. But it helps to see it that way. It just does help. So good. Any questions on combining like terms? Okay. Question? Do we need parentheses? Is that what you're saying? Oh, okay, no question. Somebody, yes, it's always a good idea to put parentheses on there. You don't have to, though. If you don't like writing it that way, you could change it back to 12x minus 9. So note, if someone legit has a question, please ask. You can type it, you can write it, but let's not write over someone's question if they legitimately have one. Okay, someone wrote yes, but then no on it. So, okay, I'm gonna keep on cruising. If you think of your question, let me know, and we will definitely go through it. Because questions are important. Good. Oh, question. Think of -9. Yeah, you could. Yeah, think of it as a different variable. Yeah, you definitely cannot combine it. Yeah, you're right. It's a good idea. Smart people here, smart people. Okay, so sometimes you have to do both with combining like terms and distributing, but I wanted to bring up that anytime you have a problem, that you have distributing and combining like terms, you always distribute first, always. So if you have both, if you see parentheses, you always distribute first. We're almost done, Annabelle, I promise. I know there's a lot. So we see that minus, so let's change it to a plus negative. Okay, so we're going to distribute first. So that means we don't add this -4 and this 7. Don't do that. It's so tempting to do that. Many of you will get it wrong, and that will be the reason why, because I've done it. Seriously. But just like our friends are writing on the bottom, they're perfect. Very good. You're just distributing the 7, and then that -4 is still there. But you'll combine it later. Very good. Very good. Ooh, and our person down here missed one thing. One thing our person missed. Tiny little thing. Same up here. This person missed one thing. Yes, this person got it on that, the 3. Good job. What's the person on top missing? It's also easy to do when you're dealing with a lot of numbers. No, the 7's a positive. 21's negative. That's good. But what did they forget? The variable. Yeah, we need the variable there. Very good. Good stuff. And you got it right on the bottom. That's perfect. Okay, so it's cool. It's almost like this person wrote it down here, and now here's the simplified version. Very good. So we did the distributive property. We multiplied that 7 throughout. Now we got to combine like terms. What are the like terms that we would combine up here? Oh. Kitty just wants to do math. That's all.
My cat's somewhere. I don't know where she is.
I don't know where mine is either. I don't know. Yes.
So she's not outside climbing a tree, chasing after a squirrel again.
That's good. That was terrible. Worst 2 hours ever. Okay, that's perfect. We're going to combine that -4 and that 7 to get a 3 plus -21. Perfect. Good job. And that's all we can do. Very good. Almost done with this stuff and moving into equations. Now, my other question here, guys, what would I distribute in this one here? Oh, I love how they drink water. The negative, yeah, the negative. And it's really a -1. Great catch. Good job, you guys. Seriously. So if it helps, you can draw in a -1 there. Good job. And that's what you would distribute. So we'll bring down that negative 2n, and then go ahead and distribute that negative 1. Oh, and we can write this as plus negative 10n. Yep, plus negative 1 times 9. Yep, perfect. Yeah, and I'm fine, by the way, guys. If someone is writing and you still want to write, you can write right below it. I love that. That's very good. Because then it gives us a lot of stuff to talk about with work. This is good. Yeah, oh, they're going to fix that up a little. Yeah, it's hard to write with your mouse, by the way. I have a pen, so that's why I'm good. So negative 1 times 9, and we still have that negative 2n in front. Perfect. Good stuff, guys. Yeah, good job. Right here, it looks like someone maybe combined a little too far here. They wrote negative 20n, and we wouldn't want to do that. We would want to write, we have negative 9 right here, and that's perfect, plus, yeah, you would say 10n. Yeah, that's good. And we don't need parentheses, but 10n is what you would say. Good. So we have, and then this person has it right here too. So this person is negative 9 as they make bigger parentheses. Sassy. So this person would write negative 9 plus 10n, and then we still have that negative 2n there. Oh, and you were going to add that. Sorry, my bad. Very good. So what are our like terms that we would add then? The 10n and the negative 2n, yep, and what would we get? Okay, no problemo. Yep, 8n, so our final answer is negative 9 plus 8n. Very good. Good job, you guys. Yay, math, woohoo! Good work, guys. Oops. No, I don't want it to like play forward. Okay, so now we're going to talk equation solving. So when, Kitty finally relinquished your hands, yay! So when we're doing multi-step equations, what you guys got to keep in mind is your first step is to always simplify each side of the equation by using distributive property and or combining like terms. So, and I will tell you, if you see parentheses, you're always going to do distributive property first. Always. Oh, and it looks like you could do some square rooting there, but no, we wouldn't square root there. We wouldn't have to square root just because, you're right though, square root of 16 is 4. You're totally right. But we would only square root if we saw something being squared. We would do the opposite. Good question, you guys, seriously. And then after you simplify by distributive property or combining like terms, no, we wouldn't, no square rooting. Don't have to do that here. Yeah, you would only do that if you said like if we had an equation like this, x squared equals 16, then you would take the square root of both sides to see that x equals 4. That's when you would use square root. Good observations, little jeepers. Nobody caught that yesterday. I love that someone wrote -1. That's perfect. We are distributing -1. So if we were to rewrite this, we could kind of write it in just like that. So in this example, we have a -1 that we have to distribute first. That's our very first step, is to clean up this problem by doing the distributive property. And we're going to make it look like a two-step equation, because then you'll do your adding or subtracting step, and then multiply or divide. So when we do that, we get 4 minus y plus -9. Perfect. Okay, so we did distributive property. Now we got to combine some like terms. What are the like terms that we're going to combine in this equation? The 4 and the -9. Yeah, remember, y is negative, 4 is positive, and 9 is negative. So what do we get when we combine 4 with -9? Yep, you still have a negative y left over, you're right. So what's 4 and -9? Oh, someone's right. -5, yeah. 4 plus -9 is -5. So we have -5 minus y there. So we did step 1, we did distributive property. Step 2, we combined like terms. Now we're going to solve our two-step equation. No, we don't want to divide by 5. We don't want to do that. You're right. We got to get rid of that -5, though. What's the opposite of -5? Or subtracting 5. What's the opposite? +5. Is that what I saw there? I think that's what I saw. Opposite of -5 is adding 5, right? So we want to get rid of the constant first, because remember, the whole goal here, guys, is to get y by itself. So the opposite of subtracting 5 is adding 5. So then we're left with -y equals, what's 16 plus 5? 21. Thank you. Very good. 21. And then what would I divide by now? Because I don't want to know what -y is. I got to do that last step, which is that inverse operation, multiply or divide. What do I divide to turn that y positive? I'm going to divide the 21 by something. By -1. Yeah, guys, look at this. Look at this. You're right. -1. See how it's a negative y? That means there's a -1 in front of y. So we're going to divide by -1. So we're left with -21. Oh, yeah, you had it up there too. Good job. Yep, absolutely. -21 equals y. Perfect. And I was working with someone, and they were getting really confused on this part, this 21 divided by -1, just because of the negative. Don't let it fool you. It's the same as 21 divided by 1, make it a negative. Okie dokie. Oh, and we wouldn't say -21 equals -y, because we divided by -1. So now that y is positive. Yep. That's our answer. -21 equals y. Good stuff. Good stuff, guys. Questions on that? I know there's a lot going on. I know it. There's pi. Yeah, love pi. Okay, let's do this one real quick, and then I'm going to actually get into a little bit of variables on both sides, just since so many of you are done, that we can maybe work ahead a little bit. Look at this. Got a person putting stuff on there. It's awesome, but they forgot to distribute something. Such good work. They got the variable in there, but what did they forget to distribute? Yeah, that 4m. What should that 4m be? We don't have a -1 here. We're gonna distribute 5. Yeah, it should be a 20m. So we're gonna go 5 times 1 and then 5 times 4m. So it should be
30.
13 equals 5 plus 20m minus 2m. Yes, that's good. 5 plus 20m minus 2m. Good stuff. All right, so our first step is distributive property. We've done that. Always distribute first, okay? And make sure, guys, make sure that you distribute to each one in the parentheses. Okay, now we need step 2. What's step 2? What am I going to combine for step 2? Yep, 20m and 2m. What do those combine to be? 18m. Yeah, I'm sorry. I should have specified it's a -2m. That is my bad completely. So it would be definitely 18m. And now I'm in two-step equation solving territory. Woohoo! What do I get rid of first? Yep, the 5. The 5 is, what's that word? Do you guys remember the word for the 5? What's it called in my equation? It's not called goodbye. It is goodbye. No, it's not a variable. Variable is the m, but that is a valid word. I'm glad you brought that up. Very good. Oh, so close. Constant. Yes, this was so close. Constant. Yes, good job, guys. It's a constant. Oofda. I love that. Constant. Yeah. Oh, and let's check that. -13 minus 5 wouldn't be -8 because they're both two negatives. Remember, I took 13 of Cece's blankets, and then I took 5 more of her blankets. How many blankets did I take? I took 18 blankets. Yeah. Cece, you're going to have no blankets by the time I'm done. Let me tell you. So we have -18. Very good. That is what's left on that side. The 5s is canceled, and then we bring down that 18m that's left. I'm not trying to freak you out. No, I know this sounds very creepy. Okay, what am I going to divide? I'm going to divide by 18. Good job. Good job, guys. Good job. So our final answer is going to be what?
Is it thundering?
You guys, have you ever heard of thunder snow? That's pretty cool. In a cupboard. No, that's creepy. Oh no. So what is -18 divided by 18? You guys, what is -18 divided by 18? -1. Good stuff. Good work, you guys. Nice job. That is right. You guys are so funny. I love it. Okay, so now I want to talk a little bit about this today, just because we have good time, and this is a little bit of what you'll get into next week. So if you've already done your stuff, this is where you're going to want to write this stuff down, just so you get this extra step, just in case you need it. So sometimes you'll have variables on both sides of the equal sign. So guys, take a minute, and I just want to make sure we're all here and attentive. Let's take a minute and write your name on the screen. Just a little check-in. Are you alive? Are you with me? Please be with me. Aiden. Write your name on the board. Okay, chat counts 2. Very good. Jojana's there, yeah. Good. Okay, I just want to check in. Blankets. Cassandra. Grace. Good stuff. Just a little check-in. Ayub, are you there? Oh, I think you said you typed your stuff in. Ray said hello. Good stuff. That counts. Okay, just checking in. I know there's a lot. It's hard to sit here and all that stuff. Okay, good. Thank you guys. I appreciate you. Okay, so we're going to add in a little extra step. So our first step remains the same. Anytime you see parentheses, you do that distributive property. Anytime you got to combine like terms, you do that next. Step 2 is going to be get variables on the same side by doing the opposite. So you're going to add or subtract the whole term to move it over. And we're just going to do one just to introduce it for you guys. And then we'll kind of leave it there a little bit. Okay? So we first distribute, then combine like terms, then we get the variables on the same side. So let's do this first one here. Do we have to distribute in this first one at all? Oh, that's a really good catch, but we don't have any subtraction there. So we would just leave it all positive. Good catch, though. We would only do that if we had subtraction. Do I have to do distributive property at all, guys, in that first example? No. There's no parentheses. Good catch. No parentheses. What about combining like terms? Do I have to combine like terms? I kind of do because they're on opposite sides, but what about on the same side of the equal sign? No, I don't. Yeah, because I'm already kind of good to go there. And I'm so sorry, my friend who's writing, I'm going to erase that, and I'll write this one just because it's the first one, and then you guys can write the next one. Sorry, guys. I know. I'm so sorry. Love. Love. I give love. Okay. So we don't need to do step 1 at all. So there's no need to distribute. There's no need to combine like terms. But we do have to get the variables on one side. So we have a 6z and a 5z. My recommendation is to pick on the little guy. Which one's the little guy? Which one's the smaller one? 6z, yep, 5z is the little guy. That's our little guy. So we're going to pick on him by doing the opposite. It's a positive 5z, so I'm going to subtract 5z. I know, pick on the little guy. That's pretty mean. So now we are left with 1z plus 17. Poor 5z, what did he do to you? You guys are so compassionate. I love it. But I'm still picking on the little guy. Just kidding. So we have 1z left over plus 17 equals 8. Now we are going to just do our regular two-step equation. We're going to get rid of our constant first, which is that 17. So we subtract 17. And that leaves us with a z equal to 9. That's it. Oh, negative 9. Negative 9. And we don't need to divide by 1 because you still get negative 9 then. But that is your answer. So that little extra step is just to get the variables on the same side. So let's do this second one real quick. And this one has a subtraction, so someone could write the rewrite. And you're right, it's got something to distribute. Woohoo! So we're going to definitely distribute that one, but we want to write it as plus negative first, just so we know what's negative. Perfection. Good work, guys. Good stuff. So then we're going to distribute that negative 3 because we have parentheses. You always have to do that first. So go ahead and distribute that negative 3. And remember, we distribute with multiplying. You want to distribute by multiplying. So what is -3 times 6? That's what you want to ask yourself. Yeah. No, not. Yes, this one right there, -18. Good stuff. That's what -3 times 6 is. And if you're still struggling a little bit with your multiplication and all that, it's okay. You can use a calculator to check those facts. Yes, you do. All you guys do. Very good. So -18, then, oh yeah, you do. All of you guys do. And then we're going to go -3 times -2. Oh, yeah. Yeah. So what's -3 times -2? Good. Very good. It's 6, but remember, negative times a negative is a positive. This is where you get that positive. Yep. Perfect. And then we still have that other side there. Excellent. Okay, so now we're done with distributive property. Do we have anything on each side that we have to combine before we can put the variables on the same side? Do we have to do any combining like terms? No, we don't. Not at all. Okay, so let's pick on the little guy. Let's move him over. Which one are we going to move over to the other side? What do you guys think? What does this guy say? We could move the 6x. We totally could. But then you'd be dealing with negatives. So I'm going to tell you to always pick the smaller one, because then you don't have to do with any negatives, right? Everybody has big brain. That's right. So let's pick on the smaller one. And how would I move that positive 2x over to the other side? I like the artwork there, guys. How would I move that positive 2x over to the other side? What's the opposite of positive 2x? Yeah, I would subtract 2x from both sides there. Very good. Good stuff. So we'd be left with -18 plus 4x equals 10. It's too good. Too good, I tell you. Okay, so now it's regular two-step equation solving. What do I do here? What would I get rid of now with that -18 or the 4? Which one goes away first? Not the 4. Not the 4. The 4 has the x, so they always go last because the x has to stay there. And the 10 is the answer. Yeah, so we would get rid of that 18. Good. Yep, and we would want to add 18 because we're already subtracting 18 there. Yep, good stuff. I didn't freeze, sorry. Did I freeze? Can you guys hear me okay? Uh-oh. Oh, you can. Okay, good. Good stuff, good. I hope not. Yep, look at that. Then we divide by 4 and we get x equals 7. Perfection. Very good. Woohoo. That is right. Very good. Okay, so here's what I want to do. We're going to take a minute and I want to try and split us into some groups. And we actually have a little bit more time here. So we will split into groups. Oh, who did I lose? Did somebody hear groups and then run away? Don't run away. I don't know who left. Who left? Oh, was that Ben? I think, oh no, Ben's still here. Oh. Ava. Oh, thank you. Okay, I'll have to follow up and make sure. Yeah, I just don't want to lose anybody just because, you know, it's okay. It's not a big deal. So this is an experiment. We're just trying with these breakout rooms. I've never really done it before. If it doesn't work, that's okay. That's no big deal. I'm going to give you an equation and we're going to try and navigate a maze here. So this is the maze that we're navigating. Look at that. Isn't that cool? I'm so excited. So today, I'll just have you work with your partner for like, yeah, for like just a few minutes. I'll just give you guys one of these equations and then we'll kind of talk it through next time, just because next time we're going to be reviewing all this stuff. Okay? So, and actually, I'm going to pull up a picture of the maze on my other screen so that I can navigate it efficiently. Perfect. And give you guys the right equations and all that. Okay, so here's what I'm going to do. Yeah, it's a little Pac-Man ghost. I love it. Ooh, someone has a theory. That's what they're saying. Okay. So, ghost face. Ah, no. So we got to navigate because there's a lot of dangers in the maze. Gotta be careful up there. So I'm just going to split us into random groups, okay? All I want you to do is I want you to get with your partner, maybe start talking it through. I will pop in. Just say hi. Tell your partner if you prefer mic or if you prefer chatting. Either way is fine, because when you chat, it'll just be chatting with your partner in that room. Sometimes it doesn't work. So if it tells me, if you get in a room and no one's there, don't panic. I'll bring us back and then just let me know that it didn't work. So, okay, we're going to give this a try. We have 13 participants here. So I'm going to split us into, oh my gosh, 5 rooms. You know, maybe I just split us into too many rooms last time. I bet you that's what I did. I'm going to split us into 5 different rooms. So there'll be 2 to 3 people in a room. Okay? So are you guys ready? You're going to get booted to a room, and then I will come in and give you guys the equation and go from there. So I believe everybody has an assigned room. Good. Okay. So go ahead and click join once you see it. Yay, it worked with everybody except Aiden. Aiden, click join. You see join? What are the numbers on this? Oh, cool. Yay, guys, it worked. Hello. Hello, hello. So good work. Good job, you guys. So the equation I am going to give you guys is, and you can write it down on a piece of paper. I don't know if, I'll have to see how you can like put something up in the breakout room. Wait, maybe I can share a whiteboard. Do you guys see a whiteboard there? Yeah, one of you can share a whiteboard and then that can be up there. Okay, so your equation that you guys are gonna work on, I'm gonna give you two because there's a lot of big brains in here. Lots of brain power. Is we're gonna have 6 plus 9x equals 51, and then I have you do -6 times n minus 7 plus n equals 82. Okay, so those are your two equations. Do you guys see them? Oh, thanks, Ben. Do you guys see them okay? Okay, so you guys work together. Ben has them in chat just in case when I leave, they leave or something. Oh, sweet. Someone asked for help. I love this. This is so cool. Okay, I will see you guys later. Hello. You've got Cece and Kaden in here. I didn't know you could ask for help. That is so cool. So I'm going to share the whiteboard and I'll give you guys your equations. You guys are going to do, I'm actually going to write this one. You're going to do -4 plus x divided by 2 equals 8. And then you're going to do 14 equals -4 minus 9x. Cool. Oh, decline. Okay, any questions there? Any questions, my friends? Does that make sense? You can see them okay? Okay, so you guys work together on it, and then, yeah, we'll probably get answers for it tomorrow. Hello, Ayub. Hello, Cassandra and Alyssa.
I tried calling you and you didn't answer.
Oh, I'm sorry. I was busy here, but I'm trying to navigate between the rooms. It's a little weird here. So I'm going to give you guys your equation.
We can't annotate. Oh, now we can. Never mind. Okay.
Okay, yeah. If you can annotate, and that's so good that you're willing to talk on mic because that's good to do. I think it makes it a lot easier if you guys are willing to do that.
I didn't know if you thought that we had the screen or not.
Oh, okay.
Figured out.
No, I'm very glad. I know this is our first time doing this, so yeah. Okay, so do you guys see those two equations okay?
Yeah.
Yeah.
Okay, so you'll work on them together, do the best you can. We won't really share about them today, we'll just work on them. So, and then I'll call you guys all back to the room as soon as we are done.
Okay.
Or as soon as I get to all the rooms. Sound good?
Mm-hmm.
Yeah.
All right, so I'm gonna go into this one. Hi guys.
Hi.
Hi. Okay, I'm gonna give you two equations, and I'm gonna give you good ones because there's a lot of big brains in here.
Oh no. I don't have big brain. I have small brain.
You have big brain.
I have small brain. Oh,
okay, so these.
Nope.
Oh yeah. Well, it's partner work. You guys will work together, and you've got Aiden and Jojana. I gotta keep saying her name right. It's on me. It's on me. Your name is too gorgeous to mess up. Look at that. Look at that. You guys work together. Oops, I wrote that weird. -2n minus. Okay, so you guys go ahead and work on that. Just work together, write it down somewhere. Is there any questions?
No, I don't think so.
Okay. Okay, I'll call you guys all back very shortly. Yes, my friend Cece, what can I do? Oh no, did it leave as soon as, oh man. Okay, well I will hand them out again tomorrow. That's good to know. So don't worry about it for now. I gotta go into the other room and assure them that I did not leave them high and dry. I'll call you guys all back in just a little bit. Hi guys. I didn't forget you. Sorry, I'm just playing around with it. So, have we been talking or anything in here? Just chit-chatting a little bit? Grace, Ray, can you guys hear me okay? Ruh-roh.
Yeah.
Oh, beautiful. Okay, yay. Okay, so I learned a few things that when I left, that the screen is gone. So I'm going to close the breakout rooms and we will tackle that next week. Okay? Which will affect you, Ray, but Grace, we have our own thing going on. So, yeah. All right. So I'm going to stop the breakout rooms and call us all back. Hi, guys.
It didn't work.
Yep, I know that as
Glad it went off the screen.
yeah, I saw that. And Cassandra, I saw you were calling to let me know. So that's okay. Now we know. And then when we actually do the activity next week, I will, I think I'll share a Google Doc with you guys that you can share. I didn't mean to bamboozle you. Sorry about that. But we experimented, we got in groups, and that's what we needed. And with that, that's all I have for you guys today. You did fabulous. Thank you. That's okay. I think I will. I'll play around with that part yet, but this gave me good information. So thank you. Thank you for the experiment. I appreciate it. You guys did good work. If you have any trouble with what you're doing, please let me know. You guys are amazing.